Hey Captains, I'm Zuff, the Community Manager for Mafia Games, and in this walkthrough we'll show you how to build your first train network in Captain of Industry. Along the way, we'll explore key systems like bidirectional lines, sidings, terminus stations, and other smart rail design techniques to keep your trains running smoothly. Let's start by transporting coal from our mine to the copper smelting plant nearby. Place a loose cargo station at each end, one for loading and one for unloading. One loose cargo module is enough for our starter train. We'll also need to place a train station adjacent to each module, which will designate all connected modules as one station. Select the track tool and click at the end of one station and create a railway connected to the other station. We can then extend the track from the other end of each station to ensure there's sufficient space for the train to pull forward so that each wagon can be serviced. To ensure the cargo stations function properly, we'll need to connect the appropriate storages with conveyor belts, as well as assigning the correct product that each station will handle. At the coal mine, make sure load is selected, and at the copper smelting plant, make sure unload is selected. Give each station an appropriate name by clicking on any station module and clicking here. This will help in the future when we're adding stations to our line. We also need to make sure that this track is bidirectional by clicking on the Set Direction tool and then clicking on the line until we see the arrows are heading in both directions. Also, keep an eye out for any track endings which are designated by a yellow bar. These can indicate that a rail wasn't properly connected. Let's also add a fuel module at one of the stations which will let the train refuel during normal operations. Station modules can be placed on top of existing tracks. Now place a train depot. This is where trains are built and sent out on the line. Make sure both tracks entering and exiting the depot are connected to the main line, as this is also where trains are sent to be salvaged. Let's create the line our train will follow using the Train Lines Manager. Click here to create a new line, and then here to add a new stop. The first stop will be the coal station, and the second stop will be the copper. You can rearrange the order of stops by clicking and dragging them up or down. To create your first train, select the depot and then click New Train. This is the Train Designer window, which will allow you to add as many engines and wagons as you see fit. Once added, engines and wagons can be rearranged by clicking and dragging them within the Train Preview window. Design your first train with one diesel engine and two hopper wagons. While we only have one loose cargo module at each station, with continuous loading and unloading, each wagon can be serviced. Before we build our train, let's go ahead and assign the line we created earlier here and then click Build. Once the materials to build the train are delivered to the depot and the train is constructed, the train will leave the depot and begin its route immediately. We've now created our first train. While this setup works fine for a single train, what happens when we need to scale up? Bidirectional tracks are exclusive by default, meaning only one train can occupy a segment at a time. To run multiple trains safely on the same line, we need to build a siding. A siding is a parallel track branching off of the main line, long enough to hold an entire train. This gives trains a place to wait without blocking the main track. Use the Track Direction tool to set the siding in one direction and the adjacent mainline segment in the opposite. This setup allows trains from either direction to enter the siding, wait safely, and continue once the path is clear. Now let's add a second train. A quick way to do this is by selecting an existing train and clicking on the Clone button. This opens the depot with a copy of the same train assigned to the same line. Once it's built, the siding proves its value. Both trains can now operate smoothly without conflict. By default, intersections and crossings are designated as no-stopping sections, preventing trains from blocking critical areas. Without no-stopping zones, our siding would not work because waiting trains would block the intersection. You can use the Set No-Stop Sections tool to add or remove these zones. This copper smelting plant also requires water for electrolysis. While rain catchers can help, they're unreliable. For a steady supply, groundwater pumps built over a groundwater deposit are a better solution. To transport water by rail, we'll build a new station with a fluid station module. Connect the pumps to the station, name it appropriately, and link it to the main rail line. Add a stretch of track at the opposite end, just like the other stations. Now let's add a fluid unloading module at the copper plant. Instead of building a separate station, we'll expand the existing one using the spare track space. Connect the module to the electrolysis machines with a storage tank in between. Create a new line using the Train Lines Manager that contains the new water loading station and the copper drop-off station to the route. We'll also create an additional siding like we did previously for this branch towards the water pumps. Now we'll build a small train with a single tanker wagon assigned to the new line, and water will now be regularly delivered to the copper plant. Our next delivery point is the iron smelting plant, which also requires coal. We'll extend the existing rail line past the far end of the coal station and build a new loose product module along with a train station near the smelters. With both the copper and iron plants drawing coal from the same station, we've created a bottleneck. Only one train can use the station at a time, leading to delays and congestion. To resolve this, we'll build a second parallel coal pickup station, fed by the same coal mine and connected to the same rail network. This gives trains more options and helps eliminate the backup. In the Train Lines Manager, we can group multiple stations together. Trains going to that stop will service whichever station in that group is available. This simple trick keeps trains flowing and reduces idle time across your network. Before we finalize this, we need to resolve a small issue. By default, bidirectional tracks are treated as exclusive zones, indicated by blue markings. Exclusive zones only allow one train to enter at a time. Because the tracks leading into both stations are connected, both lanes of the station are considered a single exclusive zone. This means that even with two stations, only one train can be serviced at a time. To resolve this, use the Set Exclusive Zones tool to remove the exclusive zone from both forks leading into the stations. This breaks the section into separate zones, allowing each station to handle a train independently. Our main line has grown busy. To increase throughput and reduce conflicts, we'll convert it into a dual unidirectional system, one track for each direction. Using the Set Direction tool, we assign one line as outbound and the other as inbound. This creates a clean, one-way loop that keeps traffic flowing smoothly in both directions. Unlike bidirectional tracks, which become blocked by opposing traffic, this setup allows multiple trains to run efficiently without interference, ideal for scaling your network. To complete the loop, we'll add turnaround loops at the end of each line. These allow trains to reverse direction and return along the inbound track, making full use of the unidirectional system. With dedicated lanes and proper return paths, our upgraded mainline can now handle more trains more reliably with no delays. Next time, we'll dive into advanced techniques to help you take full control of your rail network. If you have questions or feedback, join us on Discord or Reddit. Good luck, Captains.